Welcome to Calculus.
Our stress tolerance level has risen so high that nothing phases us.
On this episode, Stevenson will demonstrate
Let's apply that rule now in practice. So it says find the area of the region between y equals secant squared of x and y equals sine of x from x equals 0 to x equals pi over 4. So here's our bounds. Now we need to have a picture because we need to get a visualization of what's going on here. We need to know which function is above the other because remember, for the rule to work, we're going to have to make sure we put the correct functions in the correct spots. Okay, this is what we're trying to do. So let's get an idea of what this looks like. Now, sine of x isn't too bad. We should know what sine of x looks like. Now, secant squared is a little different, so let's see what that looks like. Remember, secant is 1 over cosine. So what you have to do is you have to actually type in 1 over cosine quantity squared to make it look like secant squared. Now, because there's a trig function here, what I'm going to do is I'm going to do zoom trig, and then I'm going to modify the window from there. Okay, so I kind of just want to go up to pi over 2, and I'm going to scale it by pi over 4. So I'm going to go window, and I'm going to make the min 0, and then I'm going to make the max pi over 2, and I'm going to scale the x's by pi over 4. I'm not going to worry about the x or the y values. So that's going to be 1 because I noticed the y values was scaled by 1. So that tells me it's going to go like this. Alright, so we have a sketch going on here. But this is our bounds from 0 to pi over 4. So this is the area that we want. So, what is the uppermost function? Well, draw a rectangle. If you draw a rectangle with respect to the x-axis, the function that's all the way up at the top is your f of x function. In this case, it's secant squared. Now, draw a second rectangle. That'll represent your g of x. So we can see the lower function with respect to the x-axis is the sine function. So now this integral turns into the following. Now that I have my integral set up, at this point I would just evaluate it. I could use my calculator, but because this is a pretty straightforward integral, I'm going to go ahead and do it analytically, which means I'm going to evaluate this by hand.